me out. So now I'm going to go to some that are a little bit trickier. Okay, so for this first example, and I'll write example A, not a lot of elements. Okay, just nitrogen and oxygen. And again, no metals, so I skip rule 1. Number 2, go to the non-metals. That's nitrogen, because rule 3, save hydrogen and oxygen for last. So I go to nitrogen, and I see I have 2 nitrogen here, and I have 1 here. So I might go 2. Okay, so what's left? Oxygens, right? So on my right side, I have 2 times 2 oxygen, so I have 4 oxygens here, right? And I have an O2 here. So why does this trick me up? If I go over to my left side, I only have 5 oxygen, okay? So 4, right, times what number would give me 5? I need 1 more oxygen. Well, how could I get 1 oxygen from an O2, right? So basically, 2 times what number would give me a, well, let me erase that 0 because it looks, 2 times what number would give me 1? It would be a 1/2. So that would actually work. 1/2 times 2, right? So 1/2 times 2 over 1 equals 1. So I get 1 oxygen from the half of the O2, 4 oxygen from the 2NO2, and that comes up to 5, which is what I need. Now, we haven't learned about moles yet. Okay, so for balancing, right now we're looking at this as molecules and atoms and elements, and we can't really have a half O2. So what's an easy way to get rid of that denominator? Well, just like, when you're dealing with polynomials, if you had a coefficient of a half or 2, how would you get rid of it? You would take everything and multiply everything by 2 to get rid of that denominator. So my final answer would be 2N2O5 yields 4NO2 plus O2. And that would be my final answer. And of course you want to check your work, right? So I have on this side 2 times 2, 4 nitrogen. And then I have a total of 2 times 5, 10 oxygen. Well, 4 times 2 is 8 oxygen plus the 2 from the O2. That gives me 10, and it's a wrap. So I might have moved through that a little tricky. Of course, you can pause it, go back, but let's do another one where we use that little 1/2 trick and then multiplying everything by 2. So here in this next example, I have a combustion reaction. If I'm following my rules, I would first go to metals. There's no metals. So then I'd go to nonmetals. 2 carbon, 1. Put a 2 right there. Then I would go to hydrogens. Now why hydrogens? Because I have oxygen as a diatomic. I'm going to save that for the very last. So I have 6 hydrogens. I only have 2. 3 times 2 is 6. Now this is why I save the diatomics for last. This is why I do that trick. If I look for water, I have a total of 3 oxygen, okay? If I look at CO2, 2 times 2 gives me 4 oxygens. So on this side, I have a total of 7 oxygens, okay? Now I go over here, 2 times what number would give me 7? And the whoops, sorry about that. 2 times what number would give me 7? Because I have 7 oxygens on this side, and I know I have 2. So 2 times what number is 7? That's easy. 7/2. Now some of you might think of that as 3.5. That's okay. I like fractions because the fractions, the 7/2, shows me what I need to get rid of that half in the denominator. I need to multiply everything by 2. So my final answer would be 2C2H6 plus 7O2 yields 6H2O plus 4 CO2. And that would be my final answer. And I can check that because, again, 2 times 2 would give me the 4 carbon. 2 times the 6 hydrogens would give me 12, 6 times 2. And then I have a total of 14 oxygen. I got 6 here, and I got 8 there, a total of 14 oxygen. So I hope that helps. If you have any questions, go ahead and leave them in the comment area. And I appreciate and thank you for showing up and for your patience.